Ever wonder why your AI assistant starts talking complete nonsense after just a few minutes? 1 minute it's helpful, the next, it's completely off the rails. The problem? Most AIs are trained on perfect simulators, not the messy, unpredictable way humans actually talk. Google researchers call this the Realism Gap, and it's the biggest hurdle in AI development today. But there's a breakthrough. Introducing Conv, a massive new dataset designed to bridge that gap. We're finally teaching AI to understand the full chaotic range of human emotion and conversation. Let's dive into the research that's finally making AI assistants feel, well, human.
All right, let's talk about something that I know has happened to you. Why is it that you can be having a perfectly fine conversation with an AI assistant, and then a few messages in, it just goes completely off the rails? Well, we're going to dive into some really fascinating research from Google that gets to the heart of this problem. And even better, it shows us how to fix it. You know the feeling, right? You're trying to do something simple, maybe find a specific shirt or book a table. The first couple of turns are great, but then all of a sudden the AI just completely forgets what you asked for, or it starts giving you these bizarre, irrelevant suggestions. It's super frustrating. But what if that exact feeling of frustration is the key to making these things way, way smarter? So to really get why the solution works, we first have to understand the problem. What is it about these long, complicated conversations that makes these incredibly powerful AI systems just fail? Okay, so here's the thing. It all comes down to how they're trained. You see, to make an AI better, you have to test it thousands, even millions of times. And using real people for every single one of those tests, it would take forever and cost a fortune. So what researchers do is they use other AIs to pretend to be us. These are called user simulators. And it turns out there's a huge hidden problem with them. That problem is called the Realism Gap. It's this giant canyon between how these polite AI simulators act and how we, actual, messy, impatient, sometimes confused humans really behave. Think about it. Most language models are designed from the ground up to be helpful and cooperative. So when you tell one, hey, pretend to be an angry customer, they're just not very convincing. They're too perfect, too forgiving. The researchers have this absolutely brilliant analogy for this. You wouldn't train a pilot on a flight simulator that only has perfect sunny weather, right? Of course not. You'd throw in storms, wind, engine trouble, all the unpredictable stuff. Well, it's the exact same idea for an AI. If you only train it on perfectly polite, simulated users, it's going to fall apart the second it meets a real person who's having a bad day. Okay, so we know this gap exists. But how big is it? How do you even measure it? And more importantly, how do you close it? This is where a brand new dataset called Conv comes into play. It was built specifically to drag these hidden flaws out into the light so we can build better AI testers. So to really dig in, the team collected a massive data set, over 4,000 real conversations between actual humans and an AI shopping assistant for clothing. And this wasn't just clean, simple data. It captured everything, from people who were totally thrilled to people who were getting seriously annoyed. But wait, how did they make sure they captured that full spectrum of human emotion, from happy to frustrated? This is where the experiment gets really clever. They basically set up a good cop, bad cop situation, but with AI agents. Here's how it worked. People were brought in to chat with a shopping assistant, but, and this is the key, they had no idea they were being randomly assigned to one of two different AIs. The good agent was exactly what you'd expect, helpful, efficient, great at its job. But the bad agent, it was secretly programmed to be kinda awful. It would misunderstand what you wanted and give you bad search results. This setup was genius because it guaranteed the researchers would get real, genuine reactions to both good and bad AI behavior. So now they have this incredible, rich data set full of real human reactions. The next step was to build a totally new way to test just how realistic any user simulator really is. And they came up with this 3-part framework. The first part is pretty simple: statistical alignment. You know, does the simulator talk about as much as a human? Is the vocabulary similar? The second part is a human likeness score, where they use another AI as a judge to see if it can spot the fake. But the third part, that's the one that's a total game changer. It's called counterfactual validation. This third test is really the heart of the whole thing. It's one thing for an AI to mimic patterns it's seen before. It's a whole other level for it to react believably to a situation it has never encountered. And the setup is so smart. They take a user simulator and train it only on conversations with a helpful good agent. Then they'd pull the switcheroo and have it talk to the unhelpful bad agent. A bad simulator would just keep being polite and perfect. But a good simulator, a good one should get frustrated. It should get confused. It should react just like a real person would when faced with a useless assistant. It's the ultimate stress test. So, the moment of truth. How did the best AI simulators we have today actually perform on this new, much tougher test? Well, the team put 3 different types of simulators through the ringer, and the results were pretty eye-opening. First off, that realism gap, oh yeah, it's very, very real. An AI judge could easily tell the difference between the human conversations and the simulated ones. Even the best simulators were only rated as 35% human-like. They have these little tells. Things like perfect grammar, no typos, and this weirdly predictable way of taking turns in the conversation. They're just a little too clean to be believable. But now for the most important part. Look at that last column. The simplest simulator, the one just based on a prompt, completely failed the counterfactual test. It just kept being polite to the bad agent. But the 2 more advanced data-driven simulators, they passed. Even though they had never been trained on conversations with the bad agent, they had learned the underlying patterns of human behavior so well that they started getting frustrated, just like the real users. That is a huge deal. It shows they're robust. So, what does this all boil down to? What does this mean for the future of those AI assistants we use every single day? Well, it's actually a massive step forward. What this research really gives us are a few crucial takeaways. First, the realism gap isn't just some vague idea. It's a real, measurable problem. Second, that means we have to be really careful about blindly trusting these simulators. Third, and this one's a little counterintuitive, if we make our AI assistants amazing for these perfect simulated users, we might actually be making them worse for real people. And finally, the best news, we now have the tools to actually measure this gap and, hopefully, close it. At the end of the day, the really big idea here is that by building better AI testers, we can build much, much better AI assistants. If we can create simulators that get realistically frustrated and confused, we can finally train our AI systems to handle the full, messy, unpredictable range of human conversation. And that's how we get assistants that are genuinely helpful in the real world. And all of this work leaves us with one last, really interesting question to chew on. We now know how to measure realism, which is amazing, but we still don't know how much realism is enough. Does a simulator need to be a perfect, indistinguishable copy of a human? Or is human enough, good enough to be a great training partner? Answering that question is going to be the next big adventure in building AI that truly gets us. Thanks for joining me.